Okay, so we're going to look at experiment 19 to determine the total hardness of a water sample using edta. So you're going to use a 0.01 molar edta solution, and you're going to have 50 centimeters cubed of the water sample in your conical flask rather than 25 centimeters cubed this time. You'll do your titration and you'll get roundabout figures like this. So hopefully one rough, two are more accurate and closer together by a difference of 0.1 centimeters cubed. Whichever your two titrations are closest, take them, add them, divide by 2, and you'll get your average titer that we're going to use for our calculations. Now, for this equation, we can see the edta ion, and then we can also see the hardness within the water, which is caused by calcium ions or magnesium ions. So this is going to react with the calcium ions, so it reacts in a 1-to-1 ratio. So for our equation down here, we can see that NCA and NEDTA, these will be both 1s, so 1N1. Okay, so we're just going to use that on the next page. Okay, so here's all that we should have filled in up here. So the volume of the calcium, or the water, the hard water, is 50. That's in your conical flask. We need to find out the molarity of the hardness in the water. The number that's connected to the calcium is 1. We see that from the last page. The volume of the edta, that's your average titer. The molarity of the edta would be 0.01. That should be the same for you. And the number is 1 as well. So once you put all of that into your formula, I got the molarity of the calcium to be 0.00335 moles per litre. So it's asking you to find the molarity of the calcium carbonate, and that should be the exact same answer. So whatever you get up here in your calculation is the answer here. So this is the molarity of the hardness of the calcium within that water sample that you have, which will link to its level of hardness. Now we need to convert that moles per litre into grams per litre. So to do that, we're going to use our formula. Number of moles equals mass over relative molecular mass. So the relative molecular mass of calcium carbonate is 40 plus 12 plus 3/16, which is 100. Put in whatever moles you got here, equals mass over 100. Multiply the 100 by your molarity, and you'll convert it into grams per litre. So I got 0.335 grams per litre. Okay, the last little part then. It's asking you to use the value of grams per litre of calcium carbonate to calculate the number of milligrams per litre. So all we do to change this is from grams to milligrams. So for milli, you want to move it 3 to the right if it's in grams already. So I have 0.335. So do 3 bunny hops backwards, and you get 335 milligrams per litre. So the number of milligrams is the same as parts per million, 335. So the total hardness is 335, which is greater. If you look in your book, there's a scale for what level of hardness links with what parts per million of the ions. And if it's greater than 300, it is very hard water. So my sample is very hard, and that can be your observation or conclusion as well.